Hello everyone, welcome to my channel. Let's learn computer science. Today's session is about binary arithmetic, and under binary arithmetic we'll learn about binary addition and subtraction. Syllabus reference: perform binary addition and subtraction using positive and negative binary integers and show understanding of how overflow can occur, right? Let's start. So we'll first learn about binary addition and then we'll learn about binary subtraction. So whenever we do, binary addition, we need to remember these basic rules of addition. Okay. And we very well know about how to add 0 with a 0. So 0 plus 0 is always a 0. 0 plus 1 is always a 1. 1 plus 0 is 1. Now, what is new here? New is 1 plus 1 and 1 plus 1 plus 1. So that is what we are going to understand, that why this is, uh, you know, 1 plus 1 is 0 and 1 plus 1 plus 1 is a 1. Okay. So, as I say, that 1 plus 1 is 0, right? With a 1 carry. Now, this is a carry bit here. Okay. So, if we see this in denary, so in denary, this is 1 and this is 1 and 1 0. This 1 0 in denary is 2. So, I hope you understood why this is 1 0, right? So 1 plus 1 is 0 with a carry bit, and this carry bit will be added to the next uh, bits. Okay. Now, next is 1 plus 1 plus 1 is 1 with a carry bit, right? So why is that so? Now, if I write if I write 1 plus 1 plus 1, I say this gives me 1 with a 1 carry bit, right? Now, you can write this way also. 1 plus 1 gives me 0 with 1 carry, and then I have to add this extra 1 here, which gives me 0, 1 is 1, and 1 is 1 here. So this is a carry bit, right? And in denary, if you see, 1 plus 1 plus 1 gives me 3. So this is equivalent, 1, 1 is 3 in denary. So if you convert binary 1, 1 into denary, so this is 3. Right? So you can understand it this way, right? So these basic rules we need to remember so that we can solve any questions related to binary addition. Okay. So let's do it with the help of an example. Okay. Just keep these rules being displayed. So first example is done, and second one, you can do it as a practice question, right? Okay. Now, in the example, 1 plus 1, we know that 1 plus 1 is 0. So 0 is written here with 1 carry. So carry bit I have written up here. Then 1 plus 1 plus 0. So 0 plus 1 is 1. So 1 plus 1 is, again, 1 plus 1 is 0 with 1 carry. So 0 written here and 1 is written here as carry bit. So it will be added to the next set of bits. So 1 and 0, both the zeros. So 1 and 0 gives me 1. 1 0 gives me 1, 0 1 1, 1 0 1. So this is our answer, right? So we have a practice question, so you can solve it along with me, and then you can pause the video and compare your answers. So 0 1 1 1 0 1 1 0 with 1 carry bit, which I have written here. So 1 1 again with 0. So 1 1 is 0 with 1 carry. 1 1 again 0 with 1 carry. 1 1 0 with 1 carry. So 1 1 0 1. So this is your answer. Okay. You can check these kind of questions also by converting them to denary. So you can convert this to denary, you can convert this to denary, and you can convert this to denary, right? And then you can add them, and then you can convert this to denary to check whether answer is correct. So this in denary is 31, you know. So 1, 2, 4, 8, 16, 32. So 32 plus 4 plus 2. Sorry, 30, not 31. So this is 32 plus 4 plus 2, which is 38, right? And this is 1 plus 2 plus 8 plus 16. So this is 27, right? And 38 plus 27. And here you need to convert this also. So this is 1 plus, so 2, 4, 8, 16, 32, 64. So 64 plus 1 is 65. So this is 65. And if you add this, so this is also 65. So both are same. So you can always check it this way, right? All right. So that's your binary addition. Now let's learn about binary subtraction. So here also you need to remember some basic rules of addition. So 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0, right? And these are normal rules. You already are using all these rules while normal subtraction that you do for decimal numbers also. However, when you subtract 1 from 0, it gives us 1 after 1 borrow. Now, what is this? That you need to understand. Okay. So, if I write here 0 minus 1. So, I'm saying this is 1. However, you need to borrow 1. You know, from all these previous bits, you need to borrow 1. So, 1, 0 minus 1 gives me 1. Okay. Because I have to borrow 1 and then it becomes 1, 0. And then I have to subtract 1 from that. So, 1, 0 minus 1 is 1. You can also say that because 1 plus 1 is 1, 0. So when you subtract 1, 1 from 1, 0, so it gives you 1. Right? So that is how 0 minus 1 is 1 with 1 borrow from previous bits. Okay. Now, let's understand this with the help of an example, right? One is solved for you and one is practice question that you can do. Okay, here 1 minus 1 is, we can see 1 minus 1 is 0. So 1 minus 1 is 0, right? Sorry. 1 minus 1 is 0. Then we have 0 and we have to borrow, that means. But we can't borrow from here because this is also 0. So we have to borrow from here. So from here I borrowed and this 0 became 1, 0. But I have to borrow from this also and I have to take it here. So this will become 0. This one will become 0. And this will become 1 because I am borrowing from here also. And this 0 will become 1, 0. Right? So 1, 0 minus 1 is 1. Now this is 1. 1 minus 0 is 1. And this is 0. So 0 minus 0 is 0. Now here again 0. So I have to borrow from here. So I'll borrow from this and this because I have borrowed from here. So this 1 will become 0. And this 0 will become 1, 0. So 1, 0 minus 1, 1. 0 minus 0, 0. So this is my answer, right? Okay. Now, there is one practice question for you. You can solve it. And then you can compare your answers, right? So 0 minus 1, because we have to borrow. So I borrowed from here, right? So this becomes 1, 0, right? So this becomes 1, 0. So 1, 0 minus 1 is 1, right? Now this, because I have borrowed from here, so this is 0. So again, because this is 0, I have to borrow again from here. So this becomes 1, 0 again. And this is 0 now, right? So 1, 0 minus 1, it is 1. 0 minus 0 is 0. Now I have to borrow, but I can't borrow from here. This is 0 only. So I have to borrow from here to here. So this becomes 0. This becomes 1, 0. But I have to borrow from here to here. So this will become 1 and this will become 1, 0. Now 1, 0 minus 1 is 1. 1 minus 1 is 0. 0 minus 0 is 0. So this is your answer. Okay. Now, next is add the following. These are some past paper practice questions. So add the following unsigned binary integers. Okay, so unsigned means no sign associated. It's a positive number. So this plus this. Okay, add. We have to add it. So 0 plus 0 is 0. 0 plus 1 is 1. 0 plus 1 again is 1. 0 plus 1 again it is 1. Now 1 plus 1 is 1, 0, where 1 is a carry. So I am writing carry bit here and 0 I am writing here. So now 1 plus 1, because 0 is not counted. So 1 plus 1 is 0 with 1 carry. So carry bit written here. So 1 plus 1 again, 0 with 1 carry. So carry bit is written here. Because there is no number, so I have directly written here. So answer is this. Yeah. Next question is perform the following binary subtraction. So this is a subtraction question. So it is already solved for you. You can just perform the subtraction and you can compare your answers. I have already solved 2 questions. So now you can solve it and you can compare it. Right. Now, binary subtraction, we also know that if x minus y, if we write x minus y, we can also write it like this, that x plus minus y. Okay, so for example, if I write, if I write 2 minus 1, I can also write it 2 plus minus 1. Answer will be same, right? So that is what I have written here. So there is an alternative method to perform subtraction. Instead of performing subtraction this way, we can also perform subtraction with an alternative method. So what is that alternative method? I'll just show you. So what we do here, we have to subtract 0, 1, 1, 1, 0, 1, 0, 1 from 1, 0, 1, 1, 0, 0, 1, 1. So here what we'll do, we'll take 2's complement of this number. Okay, so we'll take 2's complement of that number, right? Okay, so this number will take 2's complement, okay, to make it a negative number. As we have learned here that x minus y can also be written as x plus minus y. So we are making y as a negative number and y is this here, right? So we'll make it a negative number by taking 2's complement, right? So we'll take 2's complement of this number. And then what we'll do? Then we'll add this number to that. Okay. So 2's complement of this is this. We have learned how to calculate 2's complement and 1's complement. So you can watch that video. So 2's complement of this number is this. What we do normally, till first 1, we write the number as it is. And then for rest of the bits, we take 1's complement and we write. So that is what we have done here. So 2's complement of this number is this. Now we'll perform addition instead of subtraction, right? Because many people, they find it difficult to do subtraction, but they find it very easy to do addition questions. So that is why this method is very, very helpful for all those students. So take 2's complement of this number, make it a negative number, and then add this number to the upper number. So 2's complement of the lower number is 10001011. So we'll take addition of both the numbers, and addition is this. So 1 is 0, 1 complement, 1 carry bit. So written here, 111 is 1 with 1 carry. So 100 is 1, 01 is 1, 10 is 1, 10 is 1, 000, and 11 is 0. Now here, this is a extra bit. So if you look here, this is an 8-bit number. This is also an 8-bit number. However, the answer is coming in 9 bits, right? So this is an extra bit. So we'll just ignore this. And this bit is known as an overflow bit. We are just going to ignore that bit. We'll just understand what is this extra overflow bit. And that is part of your syllabus. So please listen to this very carefully. So overflow bit is basically, it is a condition when the result obtained from a calculation is larger than the number of bits provided for the storage. Now in this example, if you look, this is 8-bit number. This is 8-bit number, and you have to store answer in 8 bits, right? However, your answer is coming in 9 bits. So the most significant bit is known as overflow bit, and you have to ignore it because you don't have enough storage to store that, right? You don't have enough bits to store that. You have only 8 bits. However, your answer is coming in 9 bits. So 9th bit is to be discarded, right? So it is a condition when result obtained from a calculation is larger than the number of bits provided for the storage. Enough bits are not there to store the result. Extra bits are ignored and cannot be stored. So there are 1 or 2 marker questions on overflow. So you can write any 1, 2, or 3 points from here. So main point is that you do not have enough storage. You do not have enough bits to store the results, and you have to delete the extra bits which can't be stored. Okay. So with this, our topic of binary arithmetic is over. So thank you so much.